Well, good morning, and welcome to the Virtual Volumes Deep Dive. My name is Pete Fletcher, and I'm a solutions architect at VMware, focusing on virtual volumes.
I'm Pat Dirks. I manage the VMworld development team in storage at VMware.
Yeah, and so today we're gonna dive deeply into virtual volumes, but before we do, we're gonna spend about 20-30 minutes talking about the disclaimer. Telling you that, you weren't here, we weren't here, this never happened, don't repeat it. This is a public session. We are not going to share any NDA content. We may hint at things, but I promise you we don't want to lose our jobs. Yeah. So we will certainly focus on public, but still, don't share it until after the conference. Fair enough? So yeah, I've been working at VMware for a little less than a year now, focusing on virtual volumes. And in technical marketing, I get a lot of questions. I get questions from customers, partners, even VMware employees. And they always ask, sometimes they ask me really tough questions about virtual volumes, and I defer to Patrick. But then other times they'll ask me about roadmap and feature parity and which VASA provider works best and which is better, on box or off box, all these different questions. But the biggest question I get, the most common question I get, believe it or not, is why would I use virtual volumes? What's wrong with VMFS? What's wrong with what I already have? And it's a simple question, and it's hard to really answer that in just one clean statement. I mean, I tried my best to answer it in one statement, but I mean,
what more can you say?
So yeah, LUNS suck. They do suck, but that's not the only reason why virtual volumes is awesome. It's certainly a good place to start, I'd say. But yeah, it's certainly more than that. If I was going to be more specific, I would say we're going to walk through a couple of different areas around some of the pain points that most environments see in traditional environments. Starting with siloed management, having to have multiple experts, whether it's an application, a virtual administrator, a storage administrator, working in different products, having to reach out to the storage administrator to figure out things that maybe the virtual administrator just has no idea. So too many people involved in a process to just get a virtual machine up and running. The second one, which is definitely qualifies under the LUNS suckiness, is the rigid infrastructure. The idea that everything is done at the data store level. That's just not low of a level to really assign granular policies. It's a waste of resources. It's just not the most effective way to do that. And so we're gonna talk a little bit about how virtual volumes addresses that. And then I think the third one that's probably the most overlooked, but it's equally as important, is the complex processes involved. When you're talking about infrastructure, having to get on the phone, having to send emails. I had a conversation with a guy yesterday at the TAM lunch for Meet the Expert, and he said in his environment it takes never less than a week to get a LUN provisioned just because of the back and forth with his teams. And so it's a time-consuming process, but it's also sometimes manual, and there's just a better way. Another way to look at that is the three key issues that we talk a lot about with virtual volumes, the first of which is visibility. The virtual administrator, I'm sure there's plenty of them in this room, that have to provision storage. You've got a data store. You want to build a data store. So you start creating a data store, and then you look, what LUN am I going to use? Oh, well, I got a list from my Excel spreadsheet that's got about 45 LUNs. I have no idea what the capabilities are on these LUNs. I don't know if it's on flash or if it's on some old spinning disk. I don't know if the storage team is backing it up. Does it have dedupe? Does it have compression? I don't know these things from within vSphere. The second one, which is really important, is that the capabilities that you want are applied at the LUN level. This is a very LUN-centric infrastructure approach, and there's just a better way to do. We're gonna dive into that, but that is one of the key issues. Is really assigning all of your characteristics at the LUN level tends to be very limiting. And the third one also is this whole vendor-specific configuration required, kind of what we talked about earlier in the sense that getting the storage administrator involved early on and saying, this is what the requirements are for this virtual machine, so help me define a LUN that's going to meet these characteristics. And then, a month later, I'm looking at this LUN that I've provisioned, and I really don't remember why it was provisioned this way. There's no visibility into what the characteristics are, and so constantly going back and forth with the storage administrator and the virtual administrator. There's a better way. So this is just a quick example of LUN sprawl. That guy that I was talking to yesterday at lunch told me he's got a larger environment, but he has an Exchange environment. Just the Exchange environment has 333 LUNs. That's insane. There's no to have 333 LUNs. And then the chances of all of those being configured exactly the same way when humans are involved. Yeah. I mean, we are humans, right? So it's just more complex than it needs to be. And so today we're going to talk about how virtual volumes addresses these areas. And if I was going to address those at a high level, I would say that the secret sauce for virtual volumes, the first ingredient is storage policy-based management. This is a policy-based framework that we use in virtual volumes, in vSAN, and also in VAIO. Right? So this is what really gives us that ability to abstract the storage up and to prevent everything as just an API call. So when I want to actually configure with specific clarity what this virtual machine needs, because we all know all virtual machines are not created equally. I'll take that a step further and say that not all virtual disks are created equally.
That's right.
If I have
in a single VM.
Absolutely. So if I've got a SQL server, my operating system is going to have different requirements than, say, my database, than, say, my log file. And so these are different requirements. And so having storage policy-based management to granularly assign those, which is the second point, at a disk level is really something that's very powerful. And most of our customers that are getting ready to get onto vVols, this is the big attraction for them.
Right. And even if you get that LUN provisioning right the first time, because you carefully took into account which of the many LUNs you have to pick from that you have to put it on, and how to carefully put it there so that it's not in the way of other VMs that need tremendous amounts of I/O or something like that. A month, 6 months, a year from now, you're not going to remember why you put it on that particular LUN, or what made that LUN special, or why that VM had to be placed there. Again, it's very fragile, and those storage-based policies let you express exactly what a VM needs and then make it the array's problem to worry about.
Yep. And then the last one is when you're inside of virtual volumes, when you configure your data store, which is supported by an underlying storage container, you don't spend a megabyte of space until you actually provision your first virtual machine. This is not a pre-allocation of storage that you're carving up and designing up front. I mean, this is all done on demand by the virtual administrator. You used an analogy once that I love, and I'm going to steal it from you, is, vVols takes it from the retail approach. Back in the days when people would provision carving out individual LUNs and putting capabilities on the individual LUNs, pre-allocating them and pushing them out, to now the storage administrator is out of the retail business and he's in the wholesale business of actually defining upfront with a big storage container what the capabilities that can be consumed upfront, the quota or the amount of the storage container that, how much space the storage container can contain, and then he's out of the business of carving and masking LUNs all day, and the virtual administrator doesn't have to knock on his door to do it, and so he's in the wholesale business. So I love that analogy. And so, yeah, we go from that complex diagram of LUN sprawl and also LUN-centric infrastructure to something that's much more simple, potentially one data store that has all the different capabilities inside that data store, but doesn't have the adverse effects of having to compete with performance with maybe bully virtual machines in that data store, because that is no longer tied to the data store level. And so having a much simpler design that gives you that capability and the performance that you're required. So you can know as an administrator that every virtual machine, every virtual disk that you have is going to receive the capability and requirements that it desires, no more and no less. And so with that, today we're going to talk about what virtual volumes are. We're going to dive a little deeper into what the architecture looks like, and Patrick's going to really explain some of the key concepts of virtual volumes. And then we're going to take a look at a day in the life of a vVol and show you exactly what it looks like when you provision a virtual volume. And we're definitely going to save time for your question and answers. My promise to you is that if we don't get all the questions answered in this session, we'll wait outside and make sure that we get them. So we really want to hear your questions. Patrick?
Okay. So this is the deep dive, and we'll go into some detail of how virtual volumes are implemented. But let's get the big picture. The key thing about virtual volumes is that instead of having the array present LUNs that are completely uniform and then making it the vSphere admin's problem to worry about, with virtual volumes, the array becomes the owner of the virtual disk. It knows about individual virtual disks as objects. And that lets us do two things. It lets the array tailor the treatment of every individual virtual disk based on the policy that's associated with it. And it lets us offload certain operations onto the array, because unlike LUNs, where there was no way for the array to tell which blocks on a VMFS file system belong to a certain disk from a certain VM, now the array knows what the object is. And when we say snapshot or something like that, the array can know exactly what to do with those snapshots. So those are two very powerful things that virtual volumes brings. And we do all of that while maintaining today's data path as is. So the SAN infrastructure that you have, or your NFS, NAS storage, still uses NFS, still uses SCSI, still uses the same fiber channel infrastructure or iSCSI that you may have. That's not changed. And we'll talk in a minute about how we do that. So the main thing from this picture, and you'll see many variants of this picture in today's presentation, don't worry, you don't have to absorb all the details in this one slide, is this VASA provider that's sitting alongside the array. That is the key to, when Pete said the number one ingredient in the secret sauce is SPBM, that VASA provider is what it all goes through. And that VASA provider provides a management communication path outside of the existing data path that continues to go through these protocol endpoints. And we'll talk more about protocol endpoints in a minute. Protocol endpoints are just a sort of neutral term that we came up to refer to either LUNS in a SAN world or NFS mount points in a NAS kind of storage way. But they're just the targets for the storage that we present. And then what you see on the side there, the green objects are the storage containers that are presented. And that's a new logical abstraction that we're introducing with virtual volumes. So rather than forcing you to pre-provision things and set limits based on the size of the LUN that was created, a storage container represents a collection of storage that's available on the storage array side with a certain predefined limit that the storage admin set on that. And when I was using the analogy of going from the retail business to the wholesale business, the storage administrator is now in the business of talking with the vSphere admin and in consultation with the vSphere admin setting aside a certain amount of storage that this particular group wants to be limited to. So let's say they agree that HR is going to get a terabyte of storage and they'll have a certain mix of RAID 5 and RAID 6 and some flash and various different things. It's all different. And it's all consumed based on the storage policy that's associated with it. But the limit of 1 terabyte is associated with that storage container. And of course, you can change that easily. There's not a single file system written out there that's a terabyte in size or something. Back to Pete's point, none of this is pre-allocated. So those are the key ingredients, the storage containers, the protocol endpoints, the VASA provider, and it's all tied together with storage-based policy management. So let's look a little bit into the makeup of an individual VM now. As Pete said, many of the disks of a VM may need very different treatment. Your log, your database, your main OS disk are not all going to want the same treatment. And you don't want to spread them over 3 different LUNs just because you need different quality of service or different kind of storage back in them. You want to be able to create different storage policies on each of those virtual disks. And vVols lets you do that. So to take the place of the directory in a VMFS file system that you may have had that describes the VM, that has the VM log files, various things like that, there's now a config vVol. And we actually write a small file system on that. And that's basically there just to hold those few files that tie the VM together. But the bulk of the storage is consumed in these data vVols that are individually provisioned with their own storage policy. So each individual data disk can have very different quality of service, very different kind of backing storage, exactly as needed, tailored for the particular case. And then there's a few other specific types of vVols that we expose to the storage array just to let it tailor the treatment that it gives to that particular vVol based on the knowledge of the type of vVol that it is. So when you take a snapshot and you preserve the state of a VM, we create a memory snapshot, and the array can know that that memory snapshot is written completely sequentially from start to finish and probably never going to be reread until that VM is resumed and things like that. So it shouldn't devote a lot of cache to that, for instance. That's one example. Other types are swap vVols that are created only for the time that the VM is running and otherwise don't need to consume space on the array. So when it's powered on, the swap vVol is created. The VM runs, the VM is shut down, the swap vVol disappears again. And there's a few other types of vVols that we use for things like the CBRC index of a VM and things like that. But basically, most of the space is consumed in these data vVols and snapshots of them. So let's talk about the data plane in some detail.
All right. Yeah, so starting with the data plane, we'll start from the very bottom. From the very beginning, we have what is called a storage container. This is where your storage administrator in the beginning, with the exception of SolidFire, who actually places it to the virtual administrator as well. But for the most part, storage containers are created by storage administrators. The storage administrator will define upfront what capabilities the array has. And then he will probably, he can contain at least one storage container he will provision. Some vendors will have more than one, but at a minimum, you'll have just one storage container. that has the capabilities that your array can consume. After the storage container is created, oops, sorry, I went a little quick there. So the storage container is tied to a vVol data store. So a virtual administrator then actually, within vSphere is going to go and create a vVol data store and make this available to a subset of hosts that he wants to see this storage container. But he does that inside of vSphere. So a storage container on the storage is then connected to a vVol data store. What's the difference between a LUN and a storage container? Well, in a LUN world, if you've got a data store tied to a LUN, as you can see, this is a fixed size. These are pre-allocated, and there are some problems when you're trying to change it because there is a file system. If you try to change the size of a LUN, you need to reformat, right? And the fact that the other thing that we talked about in a LUN-centric world is that everything is tied to the individual LUN. Unlike a storage container is like publishing or telling you all the different things that the array can do. It doesn't mean that every virtual machine that uses this data store is going to receive all of those capabilities. What it means is that the virtual administrator now has some tools that he can choose more granular policies to assign, so he can take all of those published capabilities, transform those into VM storage policies. An easy example would be gold, silver, bronze. And so in the case of a storage administrator creating a storage container, in this case, there's two of them there. The VASA Provider, which is going to publish that into vSphere so it's visible. And then the virtual administrator can create a virtual data store. And he's created policies. So in the case of gold, silver, bronze, all of those policies can be very different. Maybe a different disk type if it's a hybrid array. Maybe some of them have deduplication. Maybe others don't. Maybe some of them just have, encryption. So all of the different capabilities, QoS, whatever your capabilities are, you can granularly design those inside of your VM storage policies.
Right. And that's very nicely abstracted with the storage capabilities. I mean, whether it's a hardware capability like flash versus spinning disk or whatever, or if it's a service that the array simply applies or doesn't apply, like dedupe or compression or something like that, they're all just surfaced uniformly in the capabilities that are associated with the storage container. And just by choosing the right requirements in the storage policy associated with a vVol, you get either the right backing storage or the right data service applied or treated in whatever way you need to.
Yep.
So the protocol endpoints, as we said, are these abstractions that we invented to refer to the endpoints in the data path. And they are just a neutral term we picked for either logical units on a SAN or mount points in an NFS environment. And the whole point of those protocol endpoints is because we want to use the existing data path to send data to vVols without requiring you to revamp your infrastructure in any way. We want vVols to coexist very nicely with the storage that you have today. So where today's logical unit first of all, are very homogeneous. Right? Every block on a logical unit, every block in a VMFS file system is the same. Not only that, but the capacity is also bound up with the logical unit that you present. So once you've created a 500 gig LUN, yeah, you can put a couple of extents together and make a larger file system out of it. But typically what everybody does is they just create another 500 gig LUN right alongside it, even if that's otherwise absolutely identical. So capacity, homogeneity, that's all features of today's LUNs. And with vVols, the protocol endpoints exist solely to be the target of I/O commands in the data path. And they have no capacity associated with them. I don't want you to get the idea that a protocol endpoint is somehow the presentation of all the logical blocks that make up a storage container. It's not like that. When a vVol is taken into use, the commands are sent to the protocol endpoint, but there's actually no storage associated with it. Typically, it's just a zero-size LUN as far as the SAN is concerned.
Wait, it's a LUN? I thought LUNs suck.
Kind of sucks, but we use it to best effect.
No, good point, though. The fact that, LUNs, this is not capable. There's no data assigned to a protocol endpoint.
That's right. And it's not as if vVols are somehow mapped onto the LUN. It's not like that. And protocol endpoints are presented by that VASA provider, so we find out about the protocol endpoints. And there may be one per array. There may be multiple per array. That's one of the things that can be different across different vendors, and they all have their own reasons based on their particular array architecture for presenting one per host or one per storage controller or one per array, depending on how they do queuing, things like that. However many there are, they're presented, and then the hosts discover them in the usual way. If it's a SAN, the host will find out all the LUNs that it's exposed to. If it's a NAS, when the virtual data store is created, as Pete said, on the host, that mount point information is transferred to the host exactly the way NFS mount points are configured on hosts today. So let's talk about management.
Absolutely. So yeah, and we've already covered a little bit about policy-based management, and so some of these are building, but the key, one of the big parts of management is using the VASA Provider to manage your environment, but it really starts with the policy-based management of SPBM. And so this is the intelligent placement. When you provision a virtual machine and you define you've already predefined what your policies are, when you're provisioning a virtual machine, that policy-based management makes decisions by talking to the VASA provider and saying, this is a gold policy, so I know I need to have these features, these services available, and then it intelligently places those vVols on your storage. And so policy-based management is the piece that handles all of those policies, enforces them, and tells you which data stores to provision your storage on based on the policies that are based on the configuration that's listed in the policy. And as I mentioned, this is all handled by the actual VASA provider. This is a software component by the individual storage partners. They manage this themselves, and some of them are different than others. I mean, this is, a lot of questions that we get is, does vVol support X feature? And the answer is, well, that depends. Which vendor are you using? Now, there are tons of features that they all cover, but some of them have different or unique capabilities that they present inside of the VASA provider. So the code for the VASA provider is completely managed by the partners, and it's just passing the certification spec of VASA inside of VMware. And so it can handle all of those different API calls. It can offload all of the data services, and it knows to provision disks onside of the array. And so the two key points that people ask me questions, they get confused between a VM storage policy and a storage capability. It's a pretty simple point, so I wanted to share with you, though, because I do get this question quite frequently. You start at the storage and you define your storage capabilities, the array, because a lot of times a storage administrator will be like, I don't want to give up control, or why would I let the virtual administrator, or vice versa? Who's doing this? I need to make sure I have the right power to do whatever. And so the key is it starts at the storage. The storage administrator defines which capabilities are available, and that is a storage capability. A VM storage policy is done inside of vSphere, leveraging the already published capabilities of the array and defining those more granular policies. And so a quick walkthrough of that. Storage administrator provisions the data store. That built a little too quickly. Okay, we'll go with it. The storage container is provisioned on the bottom. The storage capabilities are then pushed up to vSphere, where the virtual administrator can then define those granular policies. So when he provisions virtual machines, as you can see there, they have various policies, but yet they're all residing on the same data store. And so the beauty of this, and this is sometimes we get this question is, isn't this going to give us a problem with performance if everything's sitting on one big data store? And that's not the case. This is why virtual volumes is so important, is because we're no longer competing with other virtual machines that have different performance requirements, because they're all being defined individually at the disk level, and they can coexist on the same storage container. And more than that, once you have configured a policy, you also have the assurance as a virtual administrator knowing that it is on the right place. This speaks to that whole visibility part. You can see inside, once you've provisioned your policy, you know exactly that it's conformant, because SPBM is going to let you know. From the beginning, when you actually provision the virtual machine, it will tell you these data stores meet the policy that you're selecting. If you don't have a data store that even meets any of the requirements, it will not show you any data store that you can provision the virtual machine on. But after the virtual machine has been provisioned, if something happens, like if you have an outage in terms of storage, or if there's something missing, or if it's been moved, you can then check compliance and verify it's no longer in compliance. And so this is all handled by policy-based management. It will check for you to verify. So you as an administrator will always know that the policies that you've configured are going to be complied with.
And even better than that, since the storage array knows about the storage policy you've assigned to a particular object, if it knows that it's no longer meeting the objectives specified in that storage policy, it can raise an alarm with VC proactively. So if you have something provisioned on RAID 6 for the redundancy it provides, and then one disk fails in that RAID set or something like that, the array can raise an alarm and say, hey, you're no longer getting the RAID 6 level of protection that you wanted, and prompt you to go look and maybe proactively move the VM to other storage or something like that, if it can't handle it internally and replace it on the fly. So the array is now aware exactly of what you're expecting of every virtual volume and can alert you if there's something going wrong with that.
Yep. And so people ask, well, what do you see? Well, as a virtual administrator, things look very similar. You're still inside of vSphere, and you're going to provision data stores. And you're going to see virtual machines. The difference is you're going to be able to see policies. You're going to have some visibility into what capabilities these individual disks are going to have. And so you can decide what those are going to be, and you can verify that those are available. So more visibility. Storage administrator will see a storage UI, much like he normally does. He will have that storage container that he's provisioned. But they'll just be virtual volumes. But the good news is, for the storage administrator as well, is there's visibility. He knows which virtual machines are attached to the individual disks. Really helps for troubleshooting. You know, today it's hard to speak to a storage administrator as a virtual administrator to say, I'm having some contention with this virtual machine. And for the storage administrator, it's like, well, I don't know what VM or what disk this belongs to. But that goes away. Now there's true visibility because those virtual volumes are tied directly to the actual virtual machines.
Right, so you'll see many storage interfaces now suddenly showing you which VM ties together all these virtual volumes. And when a sudden I/O spike happens for some unexplained reason or something, the storage admin is not in the dark about what the source is for all these I/Os to this VMFS file system that's holding 100 VMs. You can tell exactly which vVol is being hit and which VM is associated with that. And the storage admin and the VI admin can have a conversation at a very different level about what's going on to impact the performance in your system.
Or the VI admin can just change the policy and get more performance.
Not that
All right, let's talk about the day in the life of a vVol.
So let's talk a little bit about vVols in actual operation. So, as we said, these vVols are provisioned, and it all starts when you're creating these VMs and you're associating policies with them, either with the whole VM or with each individual vVol separately. That is then communicated out of band through this VASA path. And the creation of a VM, the provisioning of a VM translates to the creation of a whole bunch of vVols on the storage side. And the array is now managing those vVols. To the vSphere side, they're just referred to by some abstract identifier, and that's it. Everything is otherwise indirected. But data still flows through these protocol endpoints that are familiar endpoints in the storage system. So the life of a vVol is kind of tracked with these bindings. A binding is this association between a virtual volume on the back end and one of these protocol endpoints on the front end that's presented. So when a VM is first created and powered on, you'll see bindings being created to create an access path for the vVols. And that binding is just to vSphere, a particular, say, secondary level LUN ID to be associated on the SAN, or a file path within an NFS mount point that's being presented as a protocol endpoint. And that association is temporary. That just lives for the life that the VM is powered on and the vVol is accessible. When the VM is powered off again, that binding goes away and there's a corresponding unbind that tells the array, I no longer need access to this particular vVol. You can go ahead and reuse that secondary level LUN ID for some other vVol later. In between, the array has the opportunity to request a change in the binding. So if there are, 4 protocol endpoints, let's say, and the array chose to use protocol endpoint 1 for the vVol when it was first bound, if the load on the protocol endpoints becomes very unbalanced and the array wants to shift the binding and the data path chosen for the different vVols, it can request a rebind, and the host will reissue a bind request, maybe be bound to PE2 now, and will transparently redirect the flow of I/O from the VM from PE1 to PE2 so that the array can free the association with PE1 and better balance vVols across all the protocol endpoints that it presents. So rebinds are just done at the request of the array. And between snapshots, we distinguish between 2 main categories of snapshots. Managed snapshots are those snapshots created by vSphere as part of normal, taking a snapshot of a VM process. But with storage policies, there's now also an ability to request the array to take snapshots on its own volition without involving vSphere at all. You can request a snapshot on a certain periodic basis or with a certain retention period or whatever the array is capable of. I mean, these capabilities presented by the array are very specific to the storage array and can vary from array to array. So you may have a whole bunch of hourly snapshots that are retained for a day or something, and then one per day for a week and various things like that. And we have APIs that let you reintroduce one of those snapshots that was taken without vSphere's knowledge and bring them in to attach them to a VM to let you pull one file out from yesterday 10 a.m.'s automatic backup or something like that. So that's a really powerful capability that you get. But snapshots themselves are also changing in a very important way. And regardless of what specific capabilities some array is presenting, they all implement offloads for snapshots as well as clones. We're focusing on snapshots here, but it's similar for clones. So if you compare how snapshots are done today, where vSphere is in charge of doing all the work of implementing the snapshot and providing the snapshot semantics. So when you create a snapshot, when you're writing a certain virtual disk and you create a snapshot of it, we create a redo log behind the scenes and tie it to the original disk. And then we change all the I/O to go to the redo log. And that piles on with every next snapshot that you take. So every new one creates a new redo log. All the new I/O goes to that redo log, and all the other ones are kept statically in place to preserve the snapshot semantics that you want. That also means that when you delete a snapshot, you're in for a very cumbersome writing out of all the blocks that you've just written to that redo log to now write them into the previous hierarchy again. And you have to wait for that whole thing to converge and get you back to the original disk that you were starting to write. With vVols, that's very different. We offload the creation of the snapshot to the array. The array can very efficiently use copy on write or whatever semantics it uses to internally track the changes and preserve the original snapshot. And the one thing we do is we shift where the I/O is happening so that even as far as vSphere is concerned, it's writing to the snapshot. The I/O is still going to the original vVol, and the snapshot is just maintaining the copies of the old blocks that you wanted to preserve that particular view of the virtual disk. With the result that when you delete the snapshot, those old blocks just get thrown away, and we continue writing the original vVol with no data transfer necessary. You're instantly back in business writing the original disk. And similarly, when you're reverting from a snapshot, let's say you're writing a snapshot and you want to take your disk back to that point in time. We briefly create a snapshot to let us back out if there are any errors created. But fundamentally, we offload the copy of all the data of whatever old blocks the array knows were written back to the original disk, and then delete the snapshot that was created as before, and delete the backout that we created, and you're back in business. So not only are snapshots very fast to take because they're offloaded to the array, they impose no I/O penalty on your VM because the job of maintaining the old view of the data is completely offloaded to the array. And they're very quick to revert to or get rid of snapshots because it's just a brief metadata operation on the array side typically.
Yeah, I heard someone say the other day, which I thought was very true and interesting, is snapshots in VMware were originally created as an undo. Right? It was essentially like, I'm going to make a change. Let me just take a snapshot and make sure that I don't want to lose what's going on. But they were never meant to be this, let's just keep that snapshot around for 365 days. Yeah. Hey, let's take 32 of these and watch my environment just blow up. Yeah. That was not the original design. And so this is exciting because Virtual Volumes has finally sort of went the same direction as many storage vendors have been doing for a long time, making just those metadata changes. We're leveraging that from our storage partners. And that's what's so exciting about vVols is you can do that with just a simple API command. vSphere is going to say, we want a snapshot. Right-click on the VM, create a snapshot, and then boom, it just goes straight to the storage array and creates that snapshot for you. So that's one of the best parts about vVols, I think. Yeah,
that's right. I mean, vVol snapshots are efficient as the LUNS snapshots that you may be taking today for your own reasons. And of course, there isn't that I/O penalty either. You remember that long chain of redo logs. If you have to go read a block, you have to potentially go and look at the first redo log, see if it maybe is in there. If it isn't in there, it could be in the next redo log because it might have been written in the previous period. But if it's a block that's never been written, you may have to go all the way back to the original disk to find the copy of the block you're looking for. All of that is not a factor with vVols. So when you're talking about an environment being brought to its knees or a VM being brought to its knees with even 3-4 levels of snapshots in place, just because of the penalty imposes on the IOPS you're getting, You get none of that with vVols. You can run with as many snapshots as you want because the snapshots are just sitting along the side, storing copies of the old blocks passively, and they're not involved in the data path per se. So let's talk about a few future considerations, and bear in mind, we're somewhat limited by how specific we can refer to the work that we're planning. I'll say a little bit more about replication because we've been getting a lot of requests for that. And obviously, if you're in an enterprise environment, you want to be able to replicate the data that you're storing, including on virtual volumes. And that'll be an area of very active work. But broadly, we want to provide a path for incorporating a variety of different data services like encryption, but also caching and other services on your data as part of the storage policies. I mean, it's the perfect place to specify how you want your disk created. And we're seeing these storage policies becoming more and more important in specifying the treatment of your data. And we'll be providing UIs to let you provide building blocks to compose these storage policies out of things that you want to be consistently used across policies. That'll be one area. All of that to make it simpler for you to manage not only at larger scale in your data, but at a larger scale in the different policies that you're tracking, to make the whole user interface simpler, and to generally let you operate in a much larger environment with less load imposed on the storage admin or the VI admin, and instead using storage policies to let the array worry about how you want a particular piece of storage treated. So replication is an area of interest because every vendor does replication differently. And we're working to sort of abstract a model that everybody can comfortably fit into. And the first obvious abstraction that we have to introduce is something we're calling replication groups. And that's the current title for them. That might still change. But a replication group is just a representation of a replication path between two sites. We're not calling them sites per se because we don't know if they're actual physical sites. We're calling them fault domains, for lack of a better word. Again, that could change in the future. But with that model, we can present any kind of replication topology that you may have configured in your arrays. And obviously, replication relationships are not things that you can easily make up on the fly. You have to provision that very explicitly. You have to provide for data links. You have to configure your array to do the replications. Yeah. But a replication group is that abstraction of a path for doing replication. And it might not be one-to-one. It could be one-to-many, or there might be many replication groups between two sites. And each one represents not only right order fidelity being maintained between all the objects in a particular replication group, but also the set of virtual volumes that should be failed over as a unit. And that provides us with a path for providing operations like synchronization of a replication group, or failover of a replication group, or a test failover operation where you present the storage on the other side as if it would have appeared if you failed it, or if you want to validate that, all through VASA. Yeah. So we see VASA as the emerging management plane to complement the existing data plane, and storage policies as the embodiment of everything the storage needs to know about the virtual volume that is being created, including replication and orchestration of failover.
Yeah, I'll say that I speak to a lot of people about virtual volumes, customers and partners, and the biggest question I get from folks, well, we get a couple, right? First, they'll say, hasn't vVols been around for 5 years? No, it has not been around for 5 years. Okay, we've been talking about it for 5 years, but it's only been around for 1.5 years. This is the first version of virtual volumes. And so the next question will be, well, what about adoption? How's the adoption going? And the answer to that is pretty simple. If you're not on vSphere 6, you're not on vVols just yet. And unfortunately, there are a lot of customers that are still on 5.x. I spoke to a guy yesterday that was on 4.x. But so, yeah, they're out there. And so that is a big upgrade. But but the percentage of folks that are upgrading and using virtual volumes when they get vSphere 6.0, that number is ridiculously high, because why not? It's free. Try it. Put it in a couple of virtual machines, see it, play with the policy, and then you'll realize it just makes sense. And ultimately, you will be on vVols. I promise you that. It's going to happen, in my opinion. So says Pete. But yeah, so the biggest inhibitor that we hear from a lot of folks, though, is, What about array-based replication? And so for the longest time, this has been heard by the dev teams, and we're looking forward to one day when that'll actually become a reality very, very soon. So we get a lot of questions. I hope I don't get fired, but that's close enough, right? We get a lot of questions, right? And so people ask, why virtual volumes? And I think we've kind of covered those key areas, and so I won't spend too much time on this. But as you can see, the use of policy-based management, offloading the data services to the array, being able to streamline everything using policy-based management, and just be more performant with granular level is some of the very key reasons that we see people excited about virtual volumes. I think the best part about coming to a VMworld like this is folks like you get to speak to all these different folks that are involved in this. Patrick Dirks, for example, he's one of the key developers. He runs the team. So that's a great resource to talk to folks like that. All the product managers are here. So if there's something missing, or if you have a question on why things are going a certain way, getting access to these folks I think is exciting. So make sure that you look at all these partners out here and ask them important questions about what they're doing with their VASA providers if they're your storage vendor. But we have quite a few of them, and the number is growing.
Yeah, and let's not forget, Vols is really a partnership. We have done our part introducing VVol 6.0, and we're continuing that evolution. But it can't happen without the storage side providing a VASA provider, implementing the capabilities, adding support for storage containers, things like that. And so if you have specific questions about, I'm using such and so storage, when am I going to get VVols, that's a great conversation to have with your storage partner and ask them what products are currently out there and what their roadmap is for introducing VVol features in the future.
Yeah, but getting a chance to talk to these folks is important. And so if you have time after lunch today, there's going to be a group discussion based around virtual volumes. But also in that same mentality, these partners are going to be joining me on a panel on Wednesday, and we're going to really have a good conversation around the transition to virtual volumes. I highly encourage you guys to come and bring your questions, because we're basically going to throw up a couple of high-level topics and just discuss. And so we really want some input from the audience on this. And so if you've got time, please come by Wednesday at 4 o'clock to the Transitioning to VVol's partner panel. In case you don't know, we do a weekly podcast at VMware. Myself and John Nicholson, we host it. It's called the Virtually Speaking Podcast. And so if you get a chance to listen to that, we'd love to hear your thoughts on that, and shoot us an email at podcast@vmware.com. And we are going to stick around for questions. And so for those of you that are leaving, thank you for coming. Fill out a survey. And for the rest of you, please stick around. We'd love to talk and answer some questions.